Years to create the world's first jumbo jet, launched in 1969. Today, that same 747 takes just 10 months to complete from nose to tail. But a new challenger looms on the 747's horizon. Part cruise ship, part spaceship, this massive super jumbo threatens to transform passenger travel in the 21st century. The 400-seat jumbo jet has reigned supreme for over 3 decades. But now the Boeing 747 has a very big rival. Boeing's European competitor, Airbus, is building a new double-decker sky giant, designed to carry a staggering 550 passengers. So far codenamed A3XX, it will be christened the Airbus A380 when it flies. For engineers like Chris Voicey, it's the challenge of a lifetime.
What we're looking at here is an A330 wing. If you try and take this and imagine that on an A3XX, in the center section, it'll be around 2.1 meters high, which means a man can actually stand up quite easily in that center section. And in terms of the overall length, it would be way outside the hangar door.
If and when it's built, the A3XX will be 2 aircraft in one, with 2 passenger cabins stacked one on top of the other. The result will be a plane that will carry 150 more people than a jumbo. Compared to the 747, A3XX will be bigger in every department. Not only is she a double-decker, her tail is 16 feet higher, her wingspan 50 feet wider. A3XX is over 300,000 pounds heavier and will be able to fly around 1,200 miles farther. According to head of marketing John Leahy, who's building a full-size mock-up of the fuselage to help him sell the idea, an aircraft this big will be a whole new flying experience.
You walk in through double wide entry doors. It'll remind you a lot of a cruise ship. There'll be a welcome reception area. There'll be an atrium in this section right here. That means 2-story atrium, much like you would have on a cruise ship.
But despite the slick marketing, selling A3XX has little to do with passengers. They buy tickets to destinations, not for particular types of aircraft. Whether Airbus can sell A3XX is entirely dependent on whether they can convince the world's airlines to buy it. And this is the place they've come to try. Britain's Farnborough Air Show is a key date on the calendar of every aircraft enthusiast, but it's also the largest open trade show on Earth. Every other year, the world's civil and military aerospace industries gather here to slug it out for dominance in a trillion-dollar business. The dogfight between Boeing and Airbus over the next superliner of the skies came to a head at Farnborough 2000. Convincing airlines to abandon the jumbo in favor of A3XX is a massive gamble for Airbus. They're taking it because they believe their plane will solve the biggest problem facing the future of air travel: gridlock in the skies.
101, descend flight level 270. Everest 101, descend flight level 270.
We've got 33, clear takeoff 27 right, surface wind is 287.
A380 speed 3327 right, 280 knots.
Since the 1960s, the number taking to the skies has done nothing but rise every year.
We virtually tripled the traffic over a 30-year period, from about 20 million to 60 million today.
Airports the world over are already operating at their limits, and passenger numbers will continue to rise in the next 20 years. So the challenge is to get more people into the air without dangerous overcrowding in the skies. An obvious answer is to pack the extra passengers onto larger planes.
Principal way in which we will accommodate more traffic is with larger aircraft through the range. So a 100-seat aircraft on a route today will be replaced over time with a 150-seat aircraft. A 200-seat aircraft will be replaced by a 250-seat aircraft, and so on through the range.
And this is why Airbus believes there's a demand for an aircraft larger than the Jumbo. German, French, Spanish, and British aerospace companies make up Airbus. When Boeing developed the 747 in the mid-1960s, Airbus had yet to build a single plane. Back then, there was no such thing as a giant airliner. Air travel was for the wealthy, exclusive members of what was called the jet set. All that changed when this man set out to build the biggest passenger plane in history. This is Joe Sutter, and this is the plane he built. An aircraft so massive, it revolutionized aviation and cost billions to develop. The 747 Jumbo.
To design this airplane at the peak of our engineering effort, we had 4,500 engineers stationed here at Boeing. Controlling that engineering effort was a tremendous management job. And we spent an awful lot of money doing it.
This is the first ever 747. 1969 saw its maiden test flight.
Feels good to sit down.
With it, the famous bulbous upper deck made its debut, and Boeing's marketing department proudly showed how the extra space in the bulge would change the flying experience for passengers. Since the first Jumbo, over 1,200 more have followed. From order to delivery, it now takes just 10 months to build one. It's made Boeing king of the skies. But it's now over 30 years old, which means the time has come for the next generation of Super Jumbo. Industry insider Keith Hayward has already seen Airbus spend $1 billion to develop one, but that's just the start. A3XX will cost billions to build.
You're dealing here with teeth-jarring numbers. I mean, Airbus are likely to put $12 billion into the investment. Now that's, I think, unprecedented in commercial fields. This is not Pepsi, this is not Coke, not even motor vehicles. This is really heavy metal.
Knocking Boeing off its perch has been Airbus's goal since the late 1970s. To do so, they've taken the skies by storm, blasting into the market with a family of 12 jetliners. In 1999, for the first time, they sold more new planes than Boeing. They now match their rival in every sector of the market except one, the Jumbo. And that's about to change. To have truly arrived, Airbus needs their own flagship passenger plane. But it's one thing to want one. For engineers to build one is the aeronautical challenge of the new century. First, Airbus looked at stretching an existing aircraft. But doing this increased operating costs significantly.
When we started to design this aircraft several years ago, we were set very stringent targets by the airlines. They asked us, and are still asking us, for 15 to 20% operating cost per seat advantages over the 747. So one way we thought we might achieve that is to try and just physically scale up an existing technology design. That does give us some advantages over existing aircraft, but it doesn't enable us to get to the 15 to 20% that the airlines want.
This meant Airbus had to develop their new Super Jumbo from scratch. Getting the design right has taken over 10 years. They have tried jumbo-like bulges. They have tried putting two fuselages side by side to produce a super wide-bodied jet. In 1992, they decided to build a double-decker. Since then, some 15 different double-decker designs have been developed to reduce airline operating costs. The single biggest hurdle to achieving these savings is keeping the weight down. When you build gigantic aircraft, you run up against a fundamental law of physics. The square cube law says that if you double the size of an airplane, it will end up 4 times heavier.
When we scale up the aircraft in size to carry more passengers, then proportionately speaking, the wing, for example, is heavier than one might have expected, and we have to fight that much harder to get the optimum design for low weight.
These physics mean engineers must walk a fine line between economy and excess weight.
If we carry weight, we have to be able to lift that weight. So we have to supply more lift, and when you supply more lift, you have more drag. More drag means more fuel burn, and more fuel burn means more operating cost.
Wing design is where lift and drag really matter. Even before it's built, A3XX's wing is a major design challenge.
The wing will be assembled from many components. The wing skin's typically of aluminium alloys, but we're running into the limits of the size of aluminium billets that can be produced by the manufacturers, and those are just the physical volume of aluminium that can be cast at any one time.
If you have to weld several metal sheets together, the wing gets heavier and potentially weaker. A structural failure in flight would be unthinkable. So it's vital to test a wing's strength. They are bent at various degrees to measure how much pressure they can withstand before the inevitable happens. Structural strength's an issue for all wings, including these on an Airbus A340. At almost 200 feet, the biggest wingspan Airbus currently produces. But it's still 25 feet shorter than the wing Chris Voicey needs to build.
On the A3XX, we're going to be challenged in terms of size. In an ideal world, we wouldn't have any joints at all. We'd buy a single piece of material to cover the whole of the bottom skin of the wing, and again for the top skin. But simply, materials in that size are not available. So what we're going to have to do is either look at the use of alternative materials at the outboard end, or using some new technology to join the basic material before we do the machining together.
The quest for this new technology is led by Janet Mitchell. She runs Airbus's Materials Research Lab. The cutting-edge research is kept secret. So secret, we can't show you all the machines. This is where new technologies, some never used before, will be tried on A3XX.
This is a new product. It's a larger product. Therefore, we need to develop new materials. Alongside the new materials, because we've got large structures now, we may have to develop new manufacturing processes to cater for the manufacture of those structures. So we do need to be on the cutting edge of the technology.
Janet and her team have spent years developing a way of welding without welds. This machine joins 2 separate metal pieces together without melting them. It does it by joining their molecules together. The drum rotates along the joint, causing friction and heat. Not enough to melt the metal, but enough to soften it. Then the rotation stirs the molecules of the 2 metal parts together. The 2 pieces become one at the molecular level. They've christened this remarkable process friction stir welding.
The friction stir welding process does not actually melt the material. It takes it to just before the melting point of the material. It makes it plastic. Whilst it's making it plastic, it's stirring the material. As it traverses along the component, it's stirring the material behind it and mixing the 2 materials.
But all this innovation will be pointless if Airbus can't sell their new plane. And that is the concern of John Leahy. From Airbus headquarters in the south of France, Leahy must convince airlines to buy this sky giant. For John, it's all about marketing. For this, he's already built A3XX in wood. The full-size fuselage mock-up was completed in the spring of 2000. It may be just wood, but it's a key weapon in the battle to sell the plane. It gives the airlines an idea of what they'll get for $230 million. It's a stage where Airbus can perform its well-rehearsed sales pitch.
If you have a choice to go on holiday, and it might, let's say 5 years from now, you're leaving London Heathrow, are you going to choose the 30-year-old 747 for the same ticket price? Or are you going to choose this new 21st century spaceship?
They were the 7 wonders of the world.
Airbus sees its plane as the next wonder of the world, and they've spent big money selling the concept.
Did the Temple of Artemis have showers? Did the lighthouse at Pharos have a casino? Did the pyramids have bedrooms? Did the statue of Zeus have a gym? No. So what was all the fuss about? You'll find all these things on the Airbus A3XX, where wonders never cease.
But if all the hype about gyms, bedrooms, and casinos is to become a reality, some basic obstacles will have to be overcome, like how to have a shower with a seatbelt on.
The propaganda war to sell the A3XX concept, I think, has seen the development of these ideas of the flying jacuzzis and the showers and the gyms and all the rest of it. There are fundamental problems about some of these marketeers' ideas. They're, in a sense, they look good if the airplane's on the ground and stationary. I think the regulatory authorities and the airlines will not want to see people away from their seats doing all sorts of active affairs.
So behind the scenes at the Farnborough Air Show, away from the glare of publicity, the real battle to sell A3XX is going on. For Airbus, selling A3XX depends on whether they can convince airlines that it won't be financial suicide. With $1 billion already spent, building a plane nobody wants would be a disaster. And the A3XX could end up the biggest white elephant in aviation history. In September 1949, this plane took off on its maiden flight. Today, its runway serves the headquarters of the British partner in Airbus, BAE Systems. But half a century ago, this is where the Bristol Aeroplane Company made the biggest commercial airliner ever built. They called it the Brabazon.
Here she comes.
It was powered by no fewer than 8 propellers, and that was the problem. The giant Brabazon made a flawless maiden flight just weeks after the world's first jet airliner was launched. Jet engines revolutionized air travel, doubling the speed planes could fly, rendering the Brabazon obsolete. No airlines bought the plane, and eventually it was sold for scrap. The Bristol Aeroplane Company went bust. That same fate almost befell Boeing when they built big, because they too almost got their design wrong. Ironically, the original jumbo jet was designed to be a double-decker, just like the A3XX today.
We were trying to develop an airplane that carried about 350 passengers, and we started out looking at putting one deck on top of the lower deck, because the airplane would be too long, we thought, without doing that.
Several models were made of the double-deck 747 configuration, but after spending millions of dollars, they were all rejected.
We developed a lot of studies on double-deck airplanes. We got into them, and believe me, it was the engineers working with me on the airplane that concluded that wasn't the way to go. The problems we were facing was, if you go double-decker, the airplane's so short, you have trouble servicing the airplane. The trucks would interfere with the engines and wings. Emergency evacuation looked like a very severe problem.
Today at the Airbus factory, Chris Voicey is facing similar problems.
When we look here at an A340 aircraft, The key consideration in locating the emergency exits is to make sure that the escape chutes can actually miss the leading edge and trailing edge of the wing. When you come to look at the 3XX, it presents some significant changes and challenges in respect of the design and location.
Modern safety regulations require emergency exits be no more than 60 feet apart. But in a double-decker, the pattern of alternating upper and lower level doors makes this very hard to achieve, especially with a giant wing in the way.
For a start, you have to make sure that the deployment of the chutes from the upper deck actually miss the deployment of the chutes from the lower deck. Now what that means is that we actually end up having to deploy one of the escape chutes actually onto the wing, and then think about how we actually get people off of the wing down to the ground.
The same design issues proved too much for the double-deck configuration of the fledgling 747. To the consternation of his bosses and the airlines, Joe Sutter decided to abandon the plan.
We were fairly well along, and people were used to looking at the double-decker, and there was a little bit of a shock. Our sales department wanted to resist it. Our management wondered whether we were doing the right thing.
This was not surprising. Changing the design almost bankrupted Boeing. By the time the single-deck version was ready to fly, Boeing was spending $5 million a day on engineering.
The company was running out of cash towards the end of the design and flight test period because we were spending an awful lot of money, but when you start one of these projects, there's no way to go except to finish it.
And finish it they did. The first jumbo was rolled out in May 1969 at Boeing's factory in Seattle. As they looked on, Boeing executives wondered if they'd made a massive commercial mistake. But their gamble paid off. The 747 became a huge hit.
There is no doubt that it revolutionized air travel in the sense that it opened air travel to a vast number of people who were denied it before, simply because the cost per seat of flying on an aircraft of that type was much lower.
If A3XX becomes a hit, Airbus expects it to make over $340 billion. But big profits mean big risks, and Joe Sutter has been there before.
They don't know what that program's going to look like 10 years from now. If they've missed the marketplace, then they've spent a lot of money and put the company at risk.
If A3XX is to sell, it has to be better than the jumbo in every way. When the 747 went into service, airports had to spend millions to redesign gates and taxiways to accommodate the giant. And today, the prospect of A3XX means airports are worried they may have to go through this all over again.
I think the A3XX is as technically challenging for us as an airport operator as the jumbo was 30 years ago. It will be 25% bigger in terms of wingspan, which on a small site such as Heathrow makes it very challenging in the way that you separate aircraft on the runway from aircraft on the taxiway, plus the whole issue of how you park them.
Every minute a plane is parked at the gate, it's not earning money. So loading passengers quickly is central to A3XX's profitability. Airbus has tried to cut out so-called choke points that will slow loading. But boarding close to 600 passengers will still be the job of the airports.
Today, the highest number we would take would be about 450, so we're a third of an increase. And we're physically talking about getting 600 people on an aeroplane and off an aeroplane, and doing that reasonably quickly.
While larger than a jumbo, airports demand A3XX will fit into existing gates. To do this, like every other plane, it must fit into an imaginary box, 262 feet square. At 261 feet 10 inches, the wingspan only just makes it. The size restriction causes a problem in getting A3XX airborne in the available length of runway. The wing needs a large enough surface area to produce the required lift to get it off the ground over the same runway distance as the 747. Without adding wingspan, A3XX will have to have the most aerodynamically advanced wing ever built to make it do this. This means extensive wind tunnel testing, costing hundreds of thousands of dollars.
We're probably looking at something like 25,000 hours total spent in the wind tunnel over about a 3 or 4 year period. And this has given us the ability to improve the aerodynamic efficiency in cruise by somewhere between 2 and 4%. Does not sound very much, but when one remembers that 1% improvement is over 1 ton of fuel saved, then you can see those numbers are very significant.
They've come up with a wing they believe will get the plane airborne using less runway and less fuel. But taking off is not only the job of the wing. The landing gear is also crucial.
Finland 181 for takeoff 27 left servicing 270 12 knots.
A3XX's undercarriage will not only support its massive weight, it will do so while traveling at Formula One racing speeds.
The aircraft is taking off typically in excess of 150 miles an hour, but the tyres you see here are rated at 235 miles an hour. That's Formula One racing car speed. The difference is my racing car weighs 600 tons, has 550 people on board.
Taking off is one thing, landing quite another. A3XX's landing gear must enable it to touch down as gently as possible, because the 600-ton plane could potentially smash holes in the runway.
Now clearly we don't want to damage the runways with such a heavy aircraft at around 600 tons, so we have to have a significant number of wheels in order to spread the load over the pavement. The challenge on A3XX is just in the sheer scale of the aeroplane and trying to meet these conflicting requirements.
Bob must be certain of the undercarriage design long before the plane is in service, so he irons out problems using a landing gear mock-up. The only difference between this and the real thing is that there's no plane attached.
This test rig is the first point at which we have all the gears and all the components working together as a system for the first time. The components are sourced from various specialist manufacturers, so we have to prove that the system as a whole operates as a system.
Bob also needs to test how the weight of the plane impacts on a real section of the runway. So crews load a full set of landing gear with 540 tons of steel to ensure it will have no more impact on the pavement than the Jumbo. The test means the finished A3XX will spread the load on the tarmac at least as well as the 747. Meanwhile, test pilots in Toulouse are figuring out how the plane will behave in the air.
Well, we use the simulator like we see here to get familiar with the aeroplane. It's not only that, we do a lot of fine-tuning before we ever get the aeroplane into the air.
All the flight surface controls are computer operated. But despite this, for pilots to physically handle A3XX is still a big challenge. In this respect, Airbus faces the same problem as the man who wanted to build the biggest plane in the world over 50 years ago.
5 months ahead of time.
During World War II, the passion of Howard Hughes, pilot and Playboy movie mogul, produced the largest aircraft ever seen. Called the HK-1 Hercules flying boat, she was known by her nickname, the Spruce Goose. She was even larger than A3XX. At 320 feet, her wingspan was 60 feet wider, the largest wingspan ever built. And she could carry 700 passengers. But she weighed almost a third less than A3XX, only 300,000 pounds, because she was built out of wood. Her wings are so thick that a person can walk inside them.
This is the root of the left-hand wing, and as you can see, it's the thickest wing ever produced. You can see the aerodynamic shape of it, and as it comes around, this is not the thickest portion. Well, if we compared this wing to a 747, and I stood in the thickest part of the 747 wing, which would be the wheel well, if I put my head all the way to the skin of the 747 wheel well, the bottom skin would be about where my knees are. And as you can see, this wing continues to go another 3 feet down.
California, builder of the monster.
Bankrolled by the War Department and his own vast fortune, the flying boat became Hughes's passion.
Weight is 200 tons and whose length
But it was so much larger than any plane ever conceived, many believed Hughes was crazy.
Nobody believed that it would fly because of its sheer size. They were limited by their own imagination, and that was something Howard Hughes did not believe in. He thought if it could happen, it could happen.
Like the Boeing 747 and the Brabazon, Spruce Goose faced many of the same technical challenges that A3XX is tackling today. Hughes's plane was so huge, using cables to move flaps and rudders simply would not work. So he developed the system of hydraulic controls to give the pilot the power he needed to move the giant flaps.
On this airplane, we ended up boosting it 225 times to 1 pound, which means if the pilot is exerting 1 pound of force on the control stick, the elevator is actually receiving 225 pounds of force. So if the hydraulic system failed, you couldn't fly the airplane. It was much too great of an effort for 1 man or even 10.
60 years later, A3XX is facing the same problems. All the modern airliners now use hydraulics that follow on from the technology developed by Howard Hughes for the Spruce Goose. They work by pushing fluid along a maze of piping to move rudders and wing flaps. This is an iron bird. Its job is to duplicate and test the hydraulic control systems of a real aircraft.
The idea of the Iron Bird is that you test not only the way the aeroplane flies, but all the electrics, all the hydraulics, all the control surfaces. Everything that will be in the aeroplane is reproduced.
In Long Beach, California.
But the Spruce Goose had no Iron Bird, and without one, getting rid of technical bugs proved the difference between success and failure. Hughes delayed completion, constantly refining the plane's engineering. These delays meant Hughes's critics in the government got louder and louder.
$40 million has been paid by the government to the Hughes Aviation Company, and nothing has been thus far received.
Originally, Washington had given Hughes millions to build 3 planes, but despite the end of the war, they had yet to see even one in the air. Hughes was called to testify before a Senate committee who would decide whether the government would continue to invest in a plane that had never flown.
May I ask a question? Well, now, if you'll just wait.
But, ever the showman, Hughes had a trick up his sleeve. In the middle of the hearing, Hughes left Washington and rushed to California. On November 2nd, 1947, Howard Hughes started the plane for what were supposed to be taxiing tests.
The pilot lifts her out of the step and holds her there as she races through the choppy sea. And with the final drive of her engines, 200 tons are airborne, 5 months ahead of time. 70 feet off the water, she stays for a mile. $23 million worth of airplane.
Hughes had confounded his critics. The Spruce Goose had flown. Giants of the sky were possible. But the Spruce Goose never flew again. Lack of customers proved to be its fatal flaw. Government subsidy stopped, and no one gave Hughes the commercial orders he needed. So Hughes employed a team of engineers to look after her until he died a recluse in 1976. She was then bought and sold by Disney before the giant came to her current home in Oregon in 1993. Today, volunteers work to restore Spruce Goose to her former glory.
This is the biggest achievement in aviation. This really is, to pull the people together and design something this large without computers. Everything was hand-drawn, everything was designed from the mind, They had no data at the time for an airplane this large. So it's astronomical what they pulled together and designed.
But technical prowess doesn't sell airplanes. The market for the Spruce Goose never existed, so it became another heroic failure in the history of giant planes. 50 years later, as the hype of the Farnborough Air Show got into full swing, the market was the priority for Airbus. By now, they'd spent $1 billion in 10 years designing A3XX. But the question on everyone's lips was, would anyone buy it? Farnborough 2000 was make or break time for Airbus. Whether they can sell A3XX depends on whether they can convince airlines that there's a big enough market for it. So the Airbus marketing team came in full force. They're buoyed by the news that 10 long years of development are nearing completion. On paper at least, they finally have a plane to sell. The hard sell is paying off, and A3XX is beginning to stir the airlines.
But 6 airlines have
As rumors that orders are imminent circulate, the time has come for rival Boeing to wheel out their big guns, like Randy Basler, Vice President of Marketing.
Always a lot of good rivalries going on, which always makes it fun. Kind of becomes a sport after a while.
A propaganda war has developed between Boeing and Airbus, with Boeing making increasingly vocal claims that there is no market for a plane bigger than a jumbo.
In the center exhibit here, what we have is what we're calling the long-range market evolution. And this is where you hear a lot about what's going on, particularly with Airbus with an A3XX, a very large airplane. And we have a little different view than they do. We see that the market developing, that there'll be more non-stop, long-range non-stop flights. And the 777 is really the airplane for passengers like ourselves who really don't like to go connecting to different airports.
When asked, they say...
Boeing is confident that its existing range, including the jumbo and the wide-bodied 777, meet airline demand. Their confidence is fueled by Randy Basler's market projections. Both Boeing and Airbus produce detailed statistical projections of future sales of new aircraft. They agree that the overall market for air travel will grow by almost 5% a year by 2020. But that's where the agreement ends.
Both Airbus and Boeing see a need for very large aircraft into the future. They all have that prediction. What they are divided on is exactly what type of large aircraft is needed to meet that market requirement.
When all the numbers are crunched, Airbus believes there's a market for around 1,200 A3XXs. But Boeing argues that the market really supports less than half that number. The success or failure of A3XX depends on whose figures the airlines believe. And with the show in full swing, it looks like some believe Airbus. Rumors that Airbus has a deal with an airline buzz around, and the press crowd into a back room to hear more. For Airbus, this is a momentous occasion. They're signing an agreement to sell 5 A3XXs to Emirates Airlines in a deal worth over $1 billion. In spite of Boeing's efforts to convince airlines otherwise, 10 years after the project began, the construction of A3XX is now a huge step closer. But while Airbus is winning the propaganda battle at Farnborough, has Boeing lost the war?
Boeing Boeing are good poker players. They sit there with their hand, they sit there with a good range of products, they sit there with options. But now I think there's a little bead of sweat beginning to come across the collective face of Boeing. They're going to have to do something about A3XX, and quite soon.
In fact, they already have. All along, Boeing had been developing a rival to take on the A3XX. Boeing's apparent U-turn means Farnborough is not the end of the battle. It's only the start. The 747 assembly line is housed in the largest building on Earth. While construction riveting together the fuselage of the current 747-400 goes on as normal, Boeing has been planning a new 747 so huge it can take on the A3XX. So far, the 747X, like the A3XX, is nothing more than a computer-generated image. But with a capacity for 530 people and development costs at a mere $4 billion, less than half of A3XX, the 747X is the trick up Boeing's sleeve.
That's been their sort of card in the hole, that they can go into a 747X, put a new wing, some stretch along the top of the 747 fuselage, and they have what they think is an answer to the A3XX challenge.
It's cheap because the idea is simple. Stretch the fuselage to fit more people and build a bigger, better wing to lift the whole thing into the sky.
This configuration includes the stretched fuselage in the forward section of the fuselage and the aft section of the fuselage. It also includes the wing that has been extended about 9 feet outboard. With this blue area is the new portion of the wing that we will be designing. And it also includes a new rake tip here where we've removed the winglet on the 747-400 and replaced it with a rake tip device.
Stretching the 747X makes it 262 feet long, 25 feet longer than A3XX. This means the plane has an extended bulbous upper deck and a new space above the main cabin. Boeing designers are busy thinking up ways to fill it, using this full-size mock-up.
We're now in the overhead space area above the main deck seating area, and as we go aft through this door, we're now entering the crew rest area, which is 8 to 14 bunks, similar to this bunk here. The purpose of this mock-up is to evaluate the space available in the overhead crown area and develop the space enough so that we know we can make it usable for bunks or galleys, or may want to use this space for computer rooms or lounges.
Passengers will have to pay to use these new facilities, which crew will also use to store food carts and provide a rest area. Dick's mock-up is only the start of the 747X project. With Boeing working intensively to make their rival a reality, after Farnborough 2000, the race to build the biggest passenger plane is starting in earnest. These computer designs now look like they'll be airborne by 2006. Now the real work begins.
Airbus will have to deliver the A3XX on time, on cost. If they don't, Boeing will begin to bite at their heels. Airbus will have to deliver all that they promise. Otherwise, they will find it hard to compete against Boeing. I mean, this really is, two pit bulls working the market.
The dream to build the biggest plane has already taken over 10 years. At last, building A3XX is expected to start in 2001. But it will be at least 5 years before we'll know whether Boeing or Airbus has won this battle to build a giant to replace the present generation of jumbo. But with A3XX, some believe we've reached the limits of conventional aircraft technology. In the future, large aircraft will have to go beyond just stretching fuselages and improving wings. This future is on display at the Farnborough Air Show. Tucked away in a small exhibit round the back of the main display is the blended wing. This plane may one day carry over 1,000 passengers, and it makes the idea of fixing wings to a tube to make a plane positively old-fashioned.
You can see that the wings and the body are in one structure. You have engines on the top of the wing, reducing noise, again also improving lift.
But it will cost billions to turn this model into something that can fly. And this will require collaboration, not competition, between Boeing and Airbus.
They're going to have to work together to overcome some of the fundamental problems of operating at high altitudes with engine emissions, noise near airports. They will have to collaborate. They will have to share research to solve a common problem.
The Super Jumbo has pushed the limits of conventional aircraft technology. For now. But when the sky is the limit, there will always be another dream of building the biggest.